Hey guys, my name is Mark Karimi. I'm in 10th grade and I would like to start explaining what limits are. So, yeah, I really like, I guess, doing math. I think it's quite relaxing, and I think if other people are able to understand it, that would make me feel even more relaxed. So, let's start with limits. Limits are a fundamental part of calculus. You can use it for rates of change. I mean, the list goes on. You can use it to find area. You can use it to approximate a value, tangent value, all that stuff. We don't deal with that now, but we do deal with the fundamentals of a limit. So now you're probably looking at this and being like, what are you talking about? Like, what do these words have to do with limits? And what even is a limit? So let me elaborate. Or not let me elaborate. Let me explain what this means. Basically, you have a function defined on an open interval around x naught. So basically saying a function with of which it has values of x, of which x naught being x can equal anything. So 1, 2, 3, 4, 5. If you have a limit, so limit as x approaches this x naught value, of which x naught can be literally 1, 6, 9, 12. F of x, so what the function at this point equals a value, L. However, what you have to realize is that the function does not need to be defined at that point. Now you're probably wondering, oh, I kind of have a general sense of idea. So, yeah. What this is and then also to elaborate that these are just basically saying that if the value is either decreasing or increasing, it's either approaching a value, it's either converging or diverging into value. Okay, so let's explain limits. Limits, in a sense, at least how I interpret it, is basically if you have a graph, okay, of which it says positive values, positive x values, negative x values, and it's the same x and y, so this is y, x, and then this is negative y values and negative positive y values. Basically, if you have a point, say for instance at 2, and it's undefined at that point, but it continues to, I guess, like it's continuous at other parts but 2, you're basically saying that if you were to take the limit of this function, let's make this f of x. So as x approaches 2, if you plug in 2 to f of x equaling 2, it's undefined. Most likely because it's something over 0. Actually, that's pretty much the reason why. If it's undefined, it's just something over 0. Or it's something over a value canceling itself out. But limit's basically saying what happens when we approach it from the negative side. So pretend this is number line, negative, positive, 2. Okay, this is what we want. Okay, you approach it from the positive and negative side. What is the behavior and actual value of that function? So let's look at it. Oh, we approach it from the negative side and we approach it from the positive side. The positive side. So if you look at the positive side of this function, you actually realize, so say for instance this is 4, okay? This so happened magically 4. You look at it from the negative side and you look at it from the positive side, and then you realize that from the negative side it's approaching 4, from the positive side it's approaching 4. So you say the limit would be 4. Now obviously you can't do this. You can't say, oh, it looks the same on both sides, hence therefore it is the same on both sides. The limit is that value. There's some sort of algebra, I guess. Later on you can use calculus to find the slope of. Yeah, basically you can't just say, oh, it looks like it's approaching that value, because in reality, you can have something like this and it'll be like that, but it won't actually approach it. It'll be discontinuous at that point, and it'll continue there. So pretend we add another example, and we'll solve this one through I guess a form of of methods of finding limits. So f of x is equal to, well, let's think of something difficult. Okay, x plus 3. Oh, it's not very difficult, but it works right now. X minus 1. And you want to find the limit as x approaches positive 1 of f of x. So obviously when you plug in 1, you get, 1, 4 times 0 over 0, which does not work. The limit does not exist. So you would say, if you were to plug that in, you would say it doesn't exist. But obviously, from what we learned from this, it doesn't exist at that point, but it can have behaviors indicating that there would be a value there if it was not something over 0. Right? So what we can do is we can use factoring, and let's say that this equation was first this plus 2x minus 3 over x plus 1. You can factor that, and then you would get that. Right. You cancel these two out. So you cancel the x minus 1, so it would not be over 0, and then you get x plus 3 is the final part because it cancels, and then you get a limit as x approaches positive 1 of x plus 3, hence being 4. So what we were able to prove was that although the limit might not exist at that, like it might not actually have a value, 1, if you plug in 1 of f of x, there's no actual value, it would not exist, but you can say the limit does exist, which is kind of strange, but it's also kind of interesting. Right. Let me look through pages in my math book to kind of just see. Alright. But, yeah, and I guess a real issue that a few of my peers, at least, are kind of confused with is, just how do you apply limits to normal problems. So we'll use a limit that I got from, I guess, a math test today. F of x is equal to sine of x over radical x. Now, you're probably wondering, this is probably quite simple, or, it's a bit trivial to kind of take a look at. Hence, what you would do, and actually you thought I was going to do it, is I'm going to leave you to do it right now, the problem, and then I'll do the solution. So, yeah, try this problem out. Trust your gut, and if you get the same answer as me, good job. If you don't, then you learn something new, which is something you have to always be grateful for. So you want to find, I'm very sorry too, I did not say what the limit exists to. Limit as x approaches 0 of sine of f of x. Yes, find that. And if you do that, you should get 0 over 0. Sine of 0 is 0. Radical 0 is just 0. But, so you'd think it does not exist, but that's incorrect. The limit does exist. You do sine of x over radical x. You rationalize. So you try removing the square root on the bottom side, and then you get sine of x radical x over x. This is the same thing as saying sine of x times radical x, and of which the sine of x is over x is equal to 1. So with knowledge prior to this, you can realize sine of x is equal to 1. And what is the limit as x approaches 0 of radical x? Well, you know that it would be 0 at that point if you plug it in. So it would be 1 times 0, meaning the limit is 0. Or the limit at that point is 0. So what you thought was the limit did not exist actually did exist, and it's actually 0. So there's different ways of, I guess, solving limits. I mean, these were just a few ways. I'm just gonna reuse paper. And there's ways that I'm probably gonna stay right now. There's factoring. I think we did an example of that already. There's conjugating. I think we also did an example of that. There's substitution. So you can use a trig substitution. There's there's substitution through trig, and then there's also just normal substitution if it's not undefined at that point. And you can use a table to find the values that are very, very close to those points. But, and there's many more other ways. There are more ways. What? I'm sorry, I'm losing right now. There are a few ways that I did not describe to evaluate limits. But what the user needs to understand is that limits exist when the values approach both sides. If the value does not approach from this side, the negative side, and it approaches from like a different thing at the positive side, it does not exist. Because limits describe what is in the neighborhood of that point. It describes the neighborhood of that point. That looks like a black hole. It looks kind of cool. Let me draw a little smiley face. Looks like a tangent. Just like... No, but what I'm trying to say is that if the limit exists at that point, it means that it approaches it from from two sides at a rate of like 0.00001 difference. So like 3.99999 and then 4.00001. That would mean the limit exists. If it was 3.999 and then 5.0001, you can't say the limit exists because it's from 4, it's from 5, therefore it's a discontinuity. Right? It would not be continuous at that point. So, I mean, I really hope I kind of helped, relieve the thought of limits being kind of confusing. If you think about it from this way, limits really should not be too confusing. And, oh, that's my arm. Yeah, but no, I think limits are not very confusing. I don't think that, but I think at first they can be confusing. But once you get a general understanding of it, there should be not very many things you have to be worried about. And I really hope you appreciated, or not appreciate, but at least took the time to just watch the video. And I hope you drop a like, leave a comment in the comment section, or just come to me in real life saying how bad the video was, and I'll appreciate it. Thank you very much. Have a good one.